So dear students, let us continue our discussion on quantum mechanics. We will discuss a lot of things about quantum mechanics. Basically, we are in a lecture series for mathematical tools of quantum mechanics. Then we will discuss about the postulates of quantum mechanics also. Okay. So basically, what we will discuss today is just commutation relation between two operators. So we will discuss a lot of things about operators. So today we will discuss about just commutation relation between two operators. Okay. Between two operators. So let us consider two operators a cap and b cap. Okay. So we have denote operator in a and b. So let us consider two operators. One is a cap and another is b cap. Okay. Now the commutation relation is defined something like this: a cap comma b cap with third bracket, and this is equal to just a cap b cap minus b cap a cap with a third bracket. So this is actually known as commutation relation between a and b. Okay. Now there is another relation called anti-commutator. So what is anti-commutation relation? So let us tell you about the anti-commutation relation. Okay. So what is anti-commutation relation? Suppose we have two operator, again a and b, but this is denoted by using the second bracket something like this, and this is equal to just a cap b cap plus b cap a cap. So this is something like this. Now if the commutation relation a cap b cap is equal to 0, then it is called that a and b commute each other. Suppose we have a cap b cap, this commutation relation is 0, then you can write simply a cap b cap minus b cap a cap equal to 0, and this is something like a cap b cap is equal to b cap a cap. So if this relation holds, then we can write that a cap and b cap commute each other. A cap and b cap commute each other. Okay. So this is a very important relation. Now let us take some examples, and the most familiar example is the commutation relation between position and momentum. Okay. So let us tell you about the commutation relation between position and momentum. Okay. So next topic is commutation relation between position and momentum. Between position and momentum. This is also a very important relation. Okay. So let us first tell you about what is the position operator and what is the momentum operator. So position operator x cap. Position operator can be written as x cap. Okay, and that is basically x. X cap is basically x. Simple x. But if you talk about position momentum operator, that is px cap, that is just minus I cross del, and for only for x component it is just del x. So this is our position operator, you have to keep in mind, and this is our, so this is a momentum operator and this is our position operator, you have to keep in mind first. Now if you talk about the commutation relation between x and px, something like x with px. Now what will be this commutation relation? This will be just x cap px cap minus px cap x cap. Now how can you find this? What will be the commutation relation between this x cap and px cap? So let us operate this operator with an wave function something like psi. So if you operate with psi, then what will be the notation? This will be just x cap with p x cap with psi. Psi let us take as a function of x simply, then x cap p x cap minus p x cap with psi. Now let us substitute the value of x cap and p x cap in terms of this. Okay, so what will be x cap with p x cap? Psi is equal to x cap means simply x, and this is minus I h cross del x minus again minus I h cross del x into x, and the whole thing will operate with psi. So if psi, so let us operate this portion and this portion with psi separately. So when this will operate with psi, what will be? So minus I h cross x, and this is del x of psi. That means this. That means basically del psi upon del x. You can write simply as this is just del psi upon del x, and this minus will be plus. So it will be plus I h cross. Now it will be del x xi. So you have to differentiate this x and psi with UV rule. So it will be just minus I h cross x del psi del x plus I h cross. So first let us fixed x. So it will be I h cross x into del psi del x plus it will be now I h cross psi and del x. So that will be just 1, and this will be cancelled out, you can see. So it will be just minus, sorry, it will be just plus I h cross psi. So what will be your x with p x cap? You can see from here, from these calculations, that if you compare this left hand side and right hand side, then you can see x with px will operate on psi, and here I h cross multiplied by psi. So if you compare both sides, then you can write that x with px cap is simply just I h cross. Okay, so this is your relation, commutation relation with position and momentum. Okay, so we will discuss further more about this change to commutation relation in the next class. Okay, for today this is enough. Okay, thank you.